This is concept PO1 and PO3, the chemical balancing and conservation of matter. Its definition is the representation of how atoms don't change in quantity between reaction and result. For example, we have the chemical formula H2 plus O2 yielding H2O, or water. Speaking of water, if you were to balance such an equation, because you would have 2 hydrogen molecules total for the for the reactant area and 2 oxygen, but you would have only 1 oxygen for the product side. That is an equal amount of molecules. And so if you balance that equation, you would end up with 2 H2 and oxygen 2 yielding 2 H2O. You would have coefficients of 2 on the hydrogen and the water. That way you would end up with values of 4 hydrogen molecules and 2 oxygen molecules on each side. Would you mind not walking through the video? Thank you. That is all. This is concept PO5, the Avogadro's constant and the concept of moles. Moles are the fundamental unit of molecular measurement, as well as Avogadro's constant is the conversion to the quantity of a compound or element's particles. Pretend you have 2 moles of hydrogen and you want to get the particles. Now, Avogadro's constant is something you multiply it by to get the particles.
What is Avogadro's number?
Avogadro's number is 6.022 times 10 to the 23rd.
Hey chemistry, Austin here. Today we're going to be talking about having to solve problems using moles. And today we're going to be talking about specifically all the calculations and math it takes to transfer or convert grams to moles, moles to volume, and back and forth. And you've already learned about particles from the previous video. So turning grams to moles, moles to grams makes it, is you put molar mass over the mole. The molar mass, there's not an exact number because it changes between each element and molecule. And to go from grams to moles, you just reverse it. You put molar mass under and 1 mole on top. Mole to volume, you put 22.4 over how many moles there are, and reverse it like the previous one, volume to moles. And you already know about particles to moles. Hey chemistry, Austin here. Today we're going to be talking about stoichiometry is a process in which molecular ratios are used to find unknown values of a reaction. Hey chemistry, Austin here. Today I'm not here, I'm down here. And you know what else is down? 1 is down from 2, like double displacement and single displacement, which are both chemical reactions. There are a lot of different types of chemical reactions. There's not just one. There's redox, single displacement, double displacement, decomposition, synthesis, acid-base reactions, and combustion. Those are so many different types. You can read them all right here if you want. It's real quick, easy, and simple. The different types of chemical reactions start with the single displacement. That's when one element swaps with another element in the reaction. Double displacement is basically the same thing, but with two elements instead. Decomposition is sort of what happens when you leave out your food, like your apple, for instance. Your apple sits out, and it rots, and it dies. And then synthesis, that, I don't know. Acid-base reactions, that's what happens when you take lemons, and you put them in a cracker. They dissolve, like in your stomach. And then combustion, that's like rockets. Now redox, that has been unknown for us humans for many years. Oof. Hey, chemistry, Austin here, and today we're going to be talking about the conversation of energy, and that's the fact that, what is it? Huh? Well, that's when energy is never destroyed. It's always here or there, you know? You don't know, that's why you're watching this video. Gotcha! Well, anyways, energy is never destroyed or created, it's only moved. When the flashlight is shining on a wall, then all the battery doesn't just run out and there's no energy anymore. It all turned into light and flashed onto the wall. That's where all the electricity went. Hey, chemistry, Austin here. Today we're going to be talking about the properties of various factors in chemical reactions. The different type of things that can affect a chemical reaction is something like pressure. Pressure can, the closer together certain gases are, the more reactions there will occur, because they're hitting each other more often. Also something like temperature, that makes them move around a lot faster, causing them to hit each other more often. It's very common also for a bigger element in general to hit another one because it has more area mass to hit each other. Hey, chemistry, Austin here. Today we're going to be talking about how acids and bases and the differences between each of them. The main determining factor in acids and bases is the pH. The higher the pH, the more likely it is to be a base, and the lower the pH, it becomes more of an acid. Now acids are different than bases in the way that they're more effective and they change physical properties more than bases do. Acids can dissolve things more easily, and bases could change things more easily. Those are the basic main differences between each substance.
Concept 13, the transfer of electrons and the process of oxidation. We have the definition here. And we also have an example for that right here. Concept PO5. It is where we apply the kinetic molecular theory to the behavior of matter. It's essentially where the decrease in volume increases pressure and reaction rate.
Hey, chemistry, Austin here. Today, we're going to learn about a very interesting lesson, and it's about...
Concept P06. Calorimetric measurements. It is fundamentally the transfer of energy by means of heat, whether it be consumed endothermically or released exothermically. That is the essential point of calorimetric measurement.
No!
Give it now.
Okay. Hey, Vsauce! Michael here. Hope you enjoyed that chemistry project. We worked a lot of time into that, and it was really entertaining for you guys to watch. Now, there's also this YouTube channel that I go to. Ha! Just kidding. Hope you enjoy.